we continue looking at the basics of electricity. Voltage. Electricity can be compared with water flowing through a pipe. A force is required to get the water to flow through the pipe. This force comes from either a water pump or gravity. Voltage is the force that is applied to a conductor that causes electric current to flow. So you have water flowing through the pipe. At the top, below here, you have the current flowing through a conductor. And the fact is, they will not just flow in one direction just like that. You have to push them, force them to move in the direction that you want. So you apply a force. This force is referred to as the electromotive force, EMF. Electrons are negative and are attracted by positive charges. They will always be attracted from a source having an excess of electrons, thus having a negative charge, to a source having a deficiency of electrons, which has a positive charge. This force required to make electricity through a conductor is called a difference of potential. Electromotive force, EMF, or more simply as voltage. So here you say it's a difference in potential, or a difference of potential, or an electromotive force, EMF, or more simply referred to as voltage. Voltage is designated by the letter E or the letter V. EMF, when someone is thinking of EMF, they would write E. When you're thinking of voltage, you write V. Now, voltage, the word voltage comes from the name Volta, which was a scientist, just like how Ampere comes from Andre Ampere, who was a scientist and researcher. Voltage comes from Volta. He himself was a scientist, an engineer, and a researcher who did a lot of work on the concept of voltage. The unit of measurement for voltage is volts, which is also designated by the letter V. Voltage sources. An electrical voltage can be generated in various ways. A battery uses an electrochemical process. A car's generator or alternator and a power plant generator utilizes a magnetic induction process. All voltage sources share the characteristics of an excess of electrons at one terminal and a shortage at the other terminal. This results in a difference of potential between the two terminals. So you have on the positive terminal of the battery, which is generally colored red, you have a shortage of electrons. So the electrons want to move over there. On the negative terminal, usually colored black, you have an excess of electrons. So the electrons want to move away from that excess over to the shortage, which is a positive. Now, concerning sources, you have the battery, which is one source. You have generators, which is another source. The generator can be turned in many cases by a steam turbine, an internal combustion engine which operates similar to the car engine, as well as in modern times an increasing amount of electricity is being generated by a flow of water, which we call hydroelectricity, where the flow of water spins blades, which also spins the generator. You have wind, where the wind blows on a blade, on a set of blades, and turn them, and then that spins the generator. And solar as well, where electricity is generated from sunlight shining on a solar panel. So we continue. Voltage circuit symbol. The terminals of a battery are indicated symbolically on an electrical drawing by two lines. The longer line indicates the positive terminal. The shorter line indicates the negative terminal. So here we have positive terminal and negative terminal. The line they're talking about is a horizontal line. It goes across. The longer line is positive, the shorter line is a negative. This is an example of what is called a schematic drawing. Now, units of measurement. Let's look at units of measurement. The following chart reflects special prefixes that are used when dealing with very small or large values of voltage. So here, kilovolt. Now remember, pre means before. So a prefix is letters or a word that's put before the name of something to describe it. The kilo is a prefix here. Kilo volt means 1000 volts. Kilo means 1000, just like how 1 kilometer means 1000 meters. The millivolt means 1,000th of a volt, just like the millimeter is 1,000th of a meter. The micro, prefix microvolt, is 1 millionth of a volt. They use MV here. That was looks like an error that they made. Micro is shown by the Greek letter mu, right? Not M, as they put here. In any case, I've seen a few errors in this document, such as misspellings, but I will highlight them as I go along and identify them. Resistance. Now, what we'll do is talk about resistance in a separate video. So I will see you in that separate video.